Hello everyone, you are welcome back to our today's class. Okay, so you remember in the last class when we did this problem, okay, that has to do with copying and completing the table of value, these tables of values, okay, for this given relation, and then this one is the linear part of it, and then we were able to use it to answer, draw the graph, this graph that is given to us according to the scale. Okay, then use it to also answer some of these sub questions, that's like the solution of this, where it lies. Okay, the maximum value of this and the corresponding value of the maximum value of this uh, quadratic problem, eh, and this corresponding value of x. We did all that in the last class. If this is the first time you are coming to this channel, I will advise you go back and check out this video so that you understand what all that we did here, down to plotting this graph with the curve and the linear, part of it, and then using it to answer the sub questions. Today, I promised us that I'm going to come back to show us how to use, this graph to answer questions like determining the gradient of this curve at a given point. Okay, so of course we know that gradient is the ratio of increase in y over the increase in x, which can be positive. The gradient can be positive, it can be negative. So this is an n-shaped parabola. We want to see how we can determine the gradient of this curve at a given point. I provided this a little explanation that can help us. I am thinking that this explanation will now lead us into this place, be able to fish out the values we can use to do calculations. But if you look here, if you look at this, a typical example of what I am talking about, an N-shaped parabola. Okay, so assuming you are asked to find or calculate the gradient of this curve at a given point, say let's assume this point here. Yeah, the gradient of this, okay, assuming this corresponds to x being 3. So one is requested to calculate the gradient of this curve at x equals to 3. So what you do is, of course, the gradient of a curve, the gradient of uh, the line, you look at something like a line that, if you look at this, because the gradient of a curve at a given point is the gradient of the tangent to that curve at that point. So if you make a tangent to this curve, let's assume we put up something like this. Let me see. I'll try to reduce it to a readable point. Okay. All right. Can you see that this line is tangent to this curve at this point? It's tangent to this curve at this point. So at that point, x is 3. I'm sure you observe what I'm saying here. Can you see that this line is tangent to that curve at that point where x is 3? You come down directly on that. You can see that. So one can use that to, calculate the gradient of that. So if I make a marking here, okay, to join this point and then join this point, can use this. This is now a triangle that is formed. So now you know that gradient g, which I can call g, is equals to change in y all over change in x. That is increase in y, the ratio of increase in y to that of increase in x, which I told you can also be negative or positive. Okay, so which we normally say is let me clean this thing. so I can see what I'm writing there, is y2 minus y1 all over x2 minus x1. Okay, now you see this point, I can call here because y is being displaced, is going in this order, it's increasing in this order. So I can call here my y1 and here my y2. Okay, and you see x is going in this order too. So I can call here this initial as my x1 and here my x2. I'm sure you can see that clearly. Okay, so look at it carefully. So that can give us, something, some numeric informations. So what I simply do is that I will just follow here and come to y-axis and determine the value that is there. That will be my y2. And my y1 is already 0 because it's landing on this, origin. Do you get? This explanation is going to help us in what I'm going to show you inside this graph now. So assuming 1 is asked to determine from this graph now the gradient of this curve, which we did last time, at x being, let's say, 2. If you come here, follow that, you can see that, you can see this. So what I need to do now is to draw a tangent that will touch this curve at this point where x is, I think x there is, 2. So I will quickly do that, as it will be a question I am answering. I will join it at the, remember, make it to be on a point where you find it a little bit convenient to take the reading. So let me stop here where x is 4. Let me take it here where x is 4, because I can, if you stretch it up here, you can still have a reading there. But let me just take it at the point where it can be a little bit convenient for me to take the reading. Okay, there, and then here. Okay, watch that. Good. I'm sure the explanation I gave on the plane will help you too. So now I am using the explanation I gave here to answer this question inside here that says determine the gradient of this curve at this point, and x there is 2. Okay, let me come closer, bring it closer. This is the origin, this is the origin, this is 1, and this is 2. Take it, look at the look at the look at the look at the tangent. Okay, touching that curve at that point. Okay, so here, do you see that based on the explanation I gave you here now, based on the explanation I gave you here now, I think you can quickly know what your x1 will be, and you can quickly know what your x2 will be. You know what your y1 will be and what your y2 will be. Okay, so I am running that calculation immediately. So you can see that here our x2 will be 4 and x1 will be 2, and up here our y2 will be 4 and our y1 is going to be 0. So assuming I am doing that calculation now, I will say the gradient is equals to y2, y2 which is 4 minus our y1 which is 0 all over our x2 which is 4 again. That's an eventuality. It mustn't happen like that all the time. 4 minus then our x1 which is 2. So obviously this is 4 over 2, which is equals to 2. So this is the gradient of this curve calculated at that point where x is what? X is 2. I'm sure that is very clear. Let me also let me also check it out on let's say somewhere here, over here can also be a possibility of one being asked calculate the gradient of this curve again, maybe at x being minus 1 over here. Okay, look at, if I, like I said earlier, you have to draw a tangent to touch that curve at that point where x is minus. Let me connect this side first. You trace that to the curve. You see the point of contact, then draw a tangent, because the gradient of this curve at this point is the gradient of the tangent to this curve at that point. So what I am possibly going to do is I am going to draw this tangent to come down to somewhere here, okay, so that this is readable. This is minus 3 and this is minus 1. Of course, somewhere here I'll follow here as well and determine the value of what y here, okay, and also determine, obviously, the value of y1 here is going to be 0. So one can also use that and come over here, assuming you are now asked to determine the gradient of this curve at x being let's assume x being this is minus 1. Let's assume at x being minus 0.5, half of this, minus 0.5. Since from here to here is 1, from here, this is the origin, from here to here is minus 1, rather, minus 1, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0.5. So I can take that up until I have done so many things inside this graph. That is why I'm trying to bring in this plain one, so that you can, get what I'm saying. But I'm trusting God this explanation will help you. Okay, so I mark this thing and get down there to the curve. Okay, of course the value, oh, that's good enough. The value of y is very clear. That's 3. Y2 is 3. Then I now need to put up a tangent to touch, this thing. Let me make it to land on this minus 2. Okay, what do I have there? Yeah, that point. Okay, a straight line, a tangent to that curve. Okay, so now can you see I can now be able to pick out the values I need? This is my y, this is my x, this is my x2, this is my x1. Okay, the displacement is in this direction. Okay, so, and this is my y2 and this is my y1. So quickly, here is my x1 and here is my x2. Here is my y1. I'm sure let me bring it closer. And here is my y2. So that is to say, if I am calculating the gradient of this curve at this point, still the same procedure, g being y2 minus, I'll bring it closer when I'm through, y2 minus y1 all over x2 minus x1. So I will come here and pick out the value of y2 from my graph here. My y2, look at that point of contact where the tangent touches this curve. The tangent to this curve is at x being, y being 3. Okay, so my y2 is 3 minus y1 being 0 all over my x2 minus 2 minus my x1 is, remember, it is 0.5, bracket minus 0.5. Please remember, this minus is in the expression. Don't confuse it with this one. This is the value of that, coordinate, the x value. Please don't confuse both, them. So here we will have 3 over minus 2. Minus into this will become minus 2 plus 0.5. So I think I can work on that now. This is now g gradient equals to 3 over Minus 2 plus 0.5 will give us minus 1.5. Yeah, minus 1.5. And I can check that out on my calculator. 3 divided by 1.5. I know the answer will be negative. Equals 3 divided by 1.5. The value gave me 2. So that will be minus 2. Minus 2. That's what we got from this calculation. Remember, my target is to show you how to be able to pick out these values. Okay? And I'm sure this explanation here is going to help you. I don't want to spend much time, on this because we are working with time here. So I think you were able to see how I was able to draw the tangent to touch that point where x is minus 0.5. Okay, and then I was able to define here as my y2, this point as my y1, here as my x2, here as my x1. Extracted the values and then place them inside this expression. I was able to calculate the gradient. We are coming back. This is an N-shaped curve or parabola. I have shown you how to calculate the gradient of, a parabola or a curve like this. I am coming back to show you how to calculate the gradient of, this a curve that is U-shaped. Okay, there are some other things I'm still going to explain as has to do with this curve in their nature, whether U-shaped or N-shaped. Okay, we are going to do all that. Thank you for staying put. I remain Victor Odigomore here. Please subscribe to this channel if this is the first time you are coming here. Watch the video that shows the explanation on how to copy and complete table of values and plot this graph so that you can follow along whatever we are doing here. God bless you, and please kindly subscribe, click the notification button so that you can be able to know what we are doing and you'll be notified, and share this video. And if God touches your heart to partner with us or to support us in what we are doing, we are targeting towards getting a very strong mathematics studio where we can be able to teach whatever we are teaching here in a more practical, realistic, way, so that we can be of help to the society. There's no other reason why we are alive than to do that. God bless you. Thank you so much.